Imagine, if you will, a Tuesday morning on August 19th, 2025. While most of the world went about its routine, a tiny speck appeared in the blue sky. That speck wasn't ordinary. It was a capsule, a traveler coming home. The Dragon glowed orange from re-entry, like a man-made star streaking across the atmosphere. SpaceX's Dragon carried precious cargo from the ISS. It wasn't just experiments, it was returning pioneers. These pioneers weren't human. They held the key to humanity's future in the void. Their journey would end in a gentle splashdown, stunning a watching world. The silence of space had been its home. Returning, friction with the air screamed its arrival. The capsule endured temperatures that could melt steel, a trial by fire. Back on Earth, mission control was calm and focused. Every calculation had been made, every contingency planned. Yet space is unforgiving. There's always the unknown. The landing's success wasn't just one company's victory, it was a testament to human ingenuity. It proved we can send creations to the heavens and bring them back safely. On board was a treasure trove, 6,700 pounds of robotic hardware. This mission, officially called CRS-42, was special from its very beginning. Its goal was twofold and honestly, profoundly ambitious. First, it had to deliver essential supplies, new scientific instruments to the International Space Station, a routine but absolutely critical task. But the second part of the mission, that's what captured the world. It was designed to be the heaviest cargo return ever attempted from the ISS. The cargo itself was revolutionary, not just weight, the nature of what was being returned. 6,700 pounds of advanced, delicate robotic systems, a challenge of an entirely new magnitude, pushing the Dragon capsule to its absolute limits. The ambition lay in the why. Why bring these robots back? Because sustainability is everything in space exploration. Sending things to space is one thing. Establishing a permanent foothold needs a circular economy. So who exactly were these robotic pioneers? They weren't the clunky, slow-moving machines you might remember. Instead, they were a new generation of explorers, a trio, known as the Archytas Project, named after an ancient Greek inventor. Weaver, a spider-like robot. It 3D prints and assembles structural trusses in vacuum. It crawls along the very structures it builds, extending the station's reach. Surgeon, a smaller, dexterous robot, equipped with high-precision manipulators and advanced imaging. It can replace a faulty sensor. It can tighten a loose bolt. It can patch a micrometeoroid impact with microscopic accuracy. Scout, a free-flying autonomous drone. AI-driven navigation inspecting the ISS exterior. It creates a real-time detailed 3D map. It spots weakening solar panels, debris, or structural strain early. Together, the Archytas trio formed an end-to-end system for construction, maintenance, and inspection. They're the forerunners of machines that will build habitats on the Moon. And on Mars, they're prototypes for mining asteroids and for constructing giant telescopes in deep space. The journey home for the Dragon capsule and its robotic passengers was, honestly, a masterclass in controlled chaos. A daring dance with the fundamental forces of physics. This maneuver had to be executed with surgical precision. Even a slight error could damage both the capsule and the station, which would be a catastrophic outcome 250 miles above the Earth. The Dragon gently pushed away, its thrusters firing in carefully calculated bursts to begin its slow, deliberate departure from the orbiting laboratory. For a few hours, it orbited the Earth alone, a tiny ship preparing for its final, fiery plunge. The true trial began with the deorbit burn. This really was the point of no return. The Dragon fired its engines one last time, slowing itself just enough to be captured by Earth's gravity. As it fell, it accelerated to speeds of over 17,000 miles per hour. At that moment, it was no longer a spacecraft. It was a meteor, but one we had to control. The capsule's heat shield, a marvel of material science, had to withstand temperatures reaching 3,000 degrees Fahrenheit. The challenge was amplified by the unprecedented weight of the cargo. The extra 6,700 pounds of robots altered the capsule's flight dynamics, making the re-entry path steeper and the forces on the structure more intense than any previous mission. Inside the capsule, the robots were secured against immense G-forces. Any component shifting during re-entry could have thrown the capsule off balance, causing it to tumble uncontrollably. The engineering that went into the internal support structures was just as critical as the heat shield on the outside. Every bracket, every strap, was designed to hold fast against forces that would crush a normal vehicle. The final act of this daring performance was the parachute deployment. At a precise altitude, after the plasma sheath of re-entry had dissipated, a set of drogue chutes deployed to stabilize and slow the capsule. Then, the main parachutes billowed open, huge canopies of red and white against the blue sky, turning a fiery projectile into a gentle floater. Their successful deployment and the final soft splashdown in the Pacific Ocean were a testament to the meticulous engineering and courage that defined the entire mission. It was truly a victory over immense technical hurdles. The moment the recovery ship confirmed the capsule was safe and sound, a wave of relief and exhilaration swept across the globe. This was more than just another successful space mission. It was, honestly, a spectacle that captured the collective imagination. News channels broke away from their regular programming. Social media feeds exploded with images of the Dragon's fiery descent and its triumphant splashdown. Students in classrooms, office workers on their lunch breaks, families in their living rooms. They were witnessing a moment of genuine wonder, a powerful reminder of what humanity can achieve when it works together on a grand vision. What stunned the world was the sheer audacity of it all, launching nearly 7,000 pounds of advanced robots, having them work in orbit, and then bringing them home. It felt like something straight out of a blockbuster movie, but it was real. A heavy, charred, real-life capsule full of futuristic robots being hoisted onto the deck of a ship. The reaction was global. The dream of space belongs to everyone. It wasn't just an American success story, it was a human one. The live streams from SpaceX and NASA were watched by millions worldwide, with comments pouring in dozens of languages. There was a sense of unity in the shared awe. SpaceX didn't just announce the success, they showed it to us. They took us along for the ride, we saw the launch, we saw the live views from space, we saw the recovery operations in real time. This open approach demystifies space travel and invites the public to be part of the journey. It changes the narrative from something done by a select few in secret to a grand adventure that all of humanity is participating in. This is why the world was stunned. We were all witnesses to the moment the future arrived, delivered by a fiery messenger from the stars. The successful return of the Archidas robots is not just an endpoint. It is, in fact, a profound beginning. It signals the dawn of a new age in our relationship with space, an age of sustainability and industrialization. For decades, our model for space has been largely disposable. We launch expensive satellites and probes, and when they break down or run out of fuel, they become space junk. This mission shatters that model. By proving we can bring back our most complex and valuable hardware from orbit, we open the door to a future where we can repair, refurbish, redeploy our assets. This is the foundation of a true space-based economy. This achievement fundamentally changes the calculus for future ambitious projects. Consider building a massive space telescope, far larger and more powerful than Hubble or James Webb. Before, such a project would be limited by what could fit into a single rocket fairing and deploy flawlessly with no chance for repairs. Now we can envision building such observatories in orbit piece by piece, using robots like Weaver, Surgeon. We can send up new instruments and upgrade them over time. The same logic applies to building permanent bases on the Moon, Mars. Robotic construction crews can be sent ahead to build habitats, landing pads, power stations before the first humans even arrive. The ability to return heavy cargo from space could revolutionize scientific research. Imagine being able to conduct long-term manufacturing experiments in the unique zero-gravity environment and then return the large, finished products to Earth for analysis and use. This could lead to breakthroughs in medicine, materials science, electronics. We could grow perfect crystals for next-generation computer chips or develop new alloys that are impossible to create in Earth's gravity. The ISS transforms from just a laboratory into a true orbital factory, with Dragon as its heavy-duty freight truck. Ultimately, this mission pushes the boundaries of what we consider possible. It accelerates the timeline for humanity's expansion into the solar system. The technologies tested and proven here, heavy re-entry, robotic construction, autonomous inspection, are the building blocks for the next great leap. They are the practical tools that will turn the science fiction dreams of Martian cities and asteroid mining into engineering problems to be solved. We are no longer just stargazers. We are becoming starfarers. This mission will be remembered as a critical inflection point, the moment we truly began to build our future in the cosmos. Look up at the night sky. The stars seem distant, untouchable. For most of human history, they were objects of myth and wonder, forever beyond our grasp. But we live in a different time. We live in an age where we can fling our creations toward those points of light and, more importantly, bring them back. The journey of the SpaceX Dragon, carrying its precious cargo of robotic pioneers, is a powerful story about the human spirit. It is a story of daring to dream on an astronomical scale and then meticulously doing the hard work to make that dream a reality. This mission is an invitation to everyone, especially the next generation, to dream big. It shows that the frontiers of exploration are not closed. In fact, they are wider open than ever before. The young person today who is inspired by this feat of engineering could be the one who designs the first city on Mars, who discovers life on a distant moon, or who harnesses the energy of a star. This is not fantasy. This is the future that missions like this are actively building, one fiery re-entry and one successful splashdown at a time. The cosmos is waiting for us. We are driven to explore. It is encoded in our DNA. It is the same impulse that pushed our ancestors out of Africa, across oceans in wooden ships, and to the highest peaks of our own planet. Now, that impulse is directed upwards, to the vast, dark ocean of space. The return of the Architas robots is more than a technical triumph. It is a reaffirmation of our exploratory nature. It shows that we are not content to remain on our home world, but are restlessly, brilliantly, and relentlessly pushing outwards. We are extending the realm of human activity beyond the thin blue line of our atmosphere. So let the story of this mission be a beacon. Let it inspire us to be bolder in our aspirations and more persistent in our efforts. The universe is vast and full of wonders, and we have only just begun to explore it. The path to the stars is paved with challenges, setbacks, and immense difficulty. But as this incredible journey shows, it is a path we are capable of walking. We are the species that looks at the heavens and does not just see lights in the dark, we see destinations. And with every launch and every return, we take one more step toward our cosmic destiny, reaching for our future among the stars.